Okay, anak-anak, second example is water molecule. So if we're going to draw the structure for water molecule, so hydrogen, oxygen, hydrogen. So at your oxygen, you have 2 lone pairs. Then that's your molecular shape. So your molecular shape is the band shape because you have 2 lone pairs, and then your bond angle is, itu saya tersalah. Itu hanyalah 104.5 degree bond angle. So now we're going to look at our Lewis structure here. So you have 2 lone pairs and 2 bonded atoms. So that means you have 2 lone pairs and you have sigma around your oxygen there. Okay. And then your oxygen will have, belum. Okay. So around oxygen, you will have 2 sigma bonds and 2 lone pairs. Okay. So that means you will have 2 unpaired electrons around your oxygen and 2 lone pairs. Okay, jangan lupakan lone pair tu. And then around your hydrogen, you will have 1 sigma bond. That means you will need 1 unpaired electron at hydrogen. Okay, so the central atom, oxygen, will have what type of hybridization? Since you have 2 unpaired electrons and 2 lone pairs, that means 2 plus 2 is 4. You need 4 hybrid orbitals. So the type of hybridization with 4 hybrid orbitals will be sp3 hybrid orbitals. Okay? So now that you have that information, you are going to fill in your you are going to do your valence orbital diagram. So we're going to start with oxygen ground state. So oxygen is in group 16. So you have 6 valence electron at ground state. So fill in 2s2 and 2p. 1, 2, 3, 4, 5, 6. 6 electrons. So your oxygen ground state already has 2 unpaired electrons. So 2 unpaired electrons, and okay, so you also have 2 lone pairs and 2 unpaired electrons. So you said you will have 2 unpaired electrons and 2 lone pairs, right? Up here, because you want to form according to your Lewis structure. So do we need to excite it? No, right? So but for formalities, just draw oxygen excited state and fill in your electrons like so. Okay, same way. So 2 lone pairs. Okay, but your 2s orbital and 2p orbital neither have the same shape nor energy. Therefore, you're going to hybridize your orbitals. So you're going to the type of hybridization is sp3. 1, 2, 3, 4. sp3 hybrid orbitals because you are mixing one of the 2s orbital with 3 of the 2p orbitals, right? So that's why you get sp3 hybrid orbitals. Okay, so fill in your electrons. 1, 2, your 2 lone pairs and your 2 unpaired electrons. Okay, so this one is already the same as this one here. So later you will make 2 sigma bonds and you will have 2 lone pairs at your oxygen. Okay, now we're going to look at our terminal atom, hydrogen. So hydrogen will have 1 sigma bond, therefore it will have 1 unpaired electron. So hydrogen at ground state has 1 electron, therefore you already have 1 unpaired electron. Okay, so that's done. So now that we have our valence orbital diagram, we are going to draw our orbital overlap. Okay, so we're going to look at our oxygen hybrid and hydrogen ground state. So first, you're going to draw the sp3 orbital for oxygen. So the sp3 orbital for oxygen will be in a tetrahedral shape. We'll have tetrahedral shape like just now. Then you're going to label each of the orbital with its name, sp3. Okay? And what atom? Oxygen. So you're going to have 2 lone pairs and 2 unpaired electrons. Okay, so just fill in your lone pair first, and then your unpaired electron. Okay? Alright. So now we're going to look at our 1s orbital. So 1s orbital of hydrogen. So I'm going to use what color? Biru. So the 1s orbital is spherical in shape. So draw the orbital and label the atom and the name of your orbital. And fill in your electron. So now your electron is paired. Your electrons are paired. So the other hydrogen 1s orbital now pair up. Alright? Okay. So now you have 2 lone pairs here. Lone pair, and you have 2 sigma bonds. Okay? So, are we done with the orbital overlap? We are done. Okay? So, if you look at your molecular shape here, you have 2 sigma bonds and here 2 lone pairs, right? Okay. So that your water molecule, salah tekan. Your water molecule will have a band shape. So this orbital overlap shows the bonding in your water molecule. How the sigma covalent bond here is formed and this one sigma covalent bond is formed. How is it formed? Alright? Okay, second example, then